Good afternoon. So a quick recap on our problem. We're building a cross-chain blockchain wallet. We need that because blockchains are now programmable and host many decentralized applications. But the problem is they do not communicate. Blockchains are silos and they cannot share data. And if you want to interact with different dApps on different blockchains, you would need different accounts. For example, if you want to use YouTube and Twitter, you would need to make them with different emails. And these emails will have to be on different applications as well. They cannot be on Gmail both. And for this to happen, it becomes pretty annoying to the user to use multiple applications on multiple blockchains. So, and these accounts on the blockchain are not even emails and passwords. They are public and private keys. And if they're compromised, you lose lots of funds. So they are very important to secure. These accounts are managed by softwares called wallets. And to log into these wallets, you need a 12 English word phrase called a mnemonic. And to use many applications on different blockchains, as I said, you need multiple wallet applications, and it becomes very hectic because these blockchains host multiple assets, not just a single asset, and transfer asset 1 to asset 2 on a different blockchain. You would need another software called a bridge. And you would need multiple bridges, a bridge for each pair of blockchains. And if you want to group all of these into one place, you would need a centralized bridge or a centralized exchange. And this becomes a problem because these have been compromised multiple of times and they lose lots and lots of user funds. So to nourish and empower a more decentralized future where blockchains are connected and users can use the dApps on them from a single interface, we wanted to create our cross-chain wallet. We wanted to create a wallet that creates an account for you on all the blockchains from the same mnemonic key, from the same mnemonic phrase, generating all your keys and managing them from one interface that also allows you to swap all your different assets and to exchange these assets between all the connected blockchains. So you have your Web3 experience from one single interface. We conducted a literature review. It was mostly using the Onion research methodology. We followed a deductive approach. We used the current documentations of the current decentralized exchanges, bridges, and all of the infrastructure we utilized. And we used a sprints method with 1 week sprints, 1 day for planning, and 6 days for implementation. Our first part of the specification is how we create the wallet accounts for you in the wallet.
Okay, so starting with the creation of mnemonics and keys generation, our design is a hierarchical deterministic wallet, which has a tree-like structure with only one seed that can be used to derive a sequence of key pairs on the different chains. So to achieve this, we need a specification. We followed Bitcoin Improvement Proposal 39, which specified a 9-step process, starting by identifying 132-bit intro. And then we split into 12 words, each of 11-bit. And then we map the 11-bit words from a dictionary. And we finally end up with a 12 random words of English called the mnemonic phrase that we give to the user. And then we can give the mnemonic phrase to a stretching function and get the 512-bit seed that can be used to generate all the key pairs. So in our implementation, for each user, we generate 1 mnemonic phrase and 1 seed. And then we created key pairs on 4 different chains: Ethereum, Polygon, Casper, and Solana.
So we have 2 models. The first is the non-custodial model. As illustrated earlier, the keys in the blockchains are the most important thing to store. So this is our password secure storage model. I will remind you of that diagram quickly. So we have in here the user's password. We will use Argon2 hashing function to hash it, and then use the single hash to encrypt the key used for encryption. So this is the encryption key we use to encrypt the user's keys and then store them. And then we encrypt that key using the single hash to store the encrypted version rather than the plain text of the encryption key. And then we use the double hash of the password to validate the login password. So when the user logs in with a new password, we are required to validate the double of the hash against the one stored in the file. And then the custodial one.
Regarding the custodial model, private keys are exported to secure cloud storage, and they are retrieved back when the user is authenticated and authorized, so that we can sign transactions using private keys.
Okay.
No, Kareem.
Sure. So as I said, blockchains host digital assets that have actual value now. And to exchange these assets, it's exactly like exchanging USDs and euros in real life. You'd need a DEX, or a decentralized exchange, or an aggregator, which is basically an interface that aggregates liquidity from multiple DEXs. We chose the Uniswap DEX because it's the most widely used decentralized exchange in the ecosystem. And basically how it works is that it's an aggregation of a set of smart contracts. Each smart contract represents a pair, for example, USD against euros, where token A and token B have an exchange rate, and the suppliers of this liquidity have LP shares. They take a small fee from your swap as revenue. And there is a formula called the constant product formula, pretty easy, to increase the price of a token against the other based on supply and demand. So how the system works is that our wallet is talking to the universal router of the Uniswap DEX router. They have multiple interfaces for this router, multiple versions, and they communicate with the Uniswap pools. They route you to the pair that you specified, and then they get a quota. And then if you agree to the price, they swap the assets for you on the blockchain where Uniswap is deployed.
So in order to transfer assets cross-chain, so for Solana, we use the wormhole bridge to transfer assets to Ethereum. And for Polygon, we use the proof of stake bridge. And for Casper, it's a new upcoming blockchain that has no bridge implementation, so we decided to implement our own. So now Omar will walk you through a demo presenting you our own implementation.
Regarding our own implementation for the bridge, Dr. Adel ElMessiry proposed a simple bridge idea that we executed. The plan involved creating an ERC20 token on the EVM chains and another corresponding CEB18 tokens on the Casper, which is one of the non-EVM blockchains. Now we will show a quick demo for how this feature works in our wallet. Users can lock a specific amount of keys on one chain. So users can lock a specific number of tokens in one chain on one side. As we can see, after the transaction is confirmed, we can see that the balance here is reduced because it is locked in our smart contract. And now when the user releases the tokens on the other side, we can see in the block explorer of Casper Live that they got an equivalent number of tokens here from the CEB18 tokens. So this is a simple idea to simulate the bridging of tokens from one chain to another by creating equivalent tokens, as we can see here. So now we will be previewing the swap feature, but I just wanted to illustrate the difference between the swap feature that I'm implementing and the swap feature that Kareem is implementing, because both of them are called swap. Kareem is trying to swap tokens from EVM chains to EVM chains. But this feature is to swap from EVM chains to non-EVM chains and vice versa. So we can see here in the demo that the user swapped some tokens on the EVM chains. We can see that the balance has been reduced here. And when we go there to Casper Live, we can see native tokens will be transferred here and the balance is increased. So the first one was non-native, the second one was native tokens, the first one was bridging, the second one was swapping from EVM to non-EVM. So swapping should be done through something called the liquidity pool, as Kareem explained. So this is in our future work, but we already started to work on it by creating this liquidity pool between Matic token and the Dahab token. This is our own token that we created using an ERC20 contracts. And there should be a fixed price to swap between these tokens on the chains, and this should be extended more to make many swaps across different chains. Now Salah will be talking about an advanced technology for another bridge model called subgraph.
So the main drawback in the design that Omar presented was it relied on a central server that we are 100% trusted to run. So we are doing the same issues that we are trying to battle in the first place, which is centralization. So we are replacing the central server with a technology called the graph. So the graph itself is a blockchain, and its main use case is to listen to events on another blockchain, and then it does some logic on these events. So here is the workflow. So if there is a DApp on Ethereum, for example, and it issues a transaction to a smart contract, the smart contract will execute a function call that will emit an event. So the graph node will listen to that event and store it into a database according to a WAS module that we are providing. So the subgraph node will take place instead of the central server. So we are transferring our trust assumptions from our central server to the subgraph.
Now with a quick demo for our wallet. Our wallet now is implemented as a browser extension, as we can see. So here, at first we create our wallet with a weak password. We have to enter a strong password. And after we create the wallet, keys are generated for us. And we click on create new wallet and choose the non-custodial model. And now these are the 12 mnemonics shown to the user. Now we log into the wallet, and if we check the balance for the 4 chains we have, we will find that the initial balance for all of them are 0. So here is Polygon, Solana, and Ethereum. So now we will send some assets to our Polygon wallet using this website. So we will get the public key and send the faucet. So now when we check in our wallet again, we should see the balance has increased. So we log in again into our wallet and we check the balance of Polygon. And as we can see, it becomes 0.5. Now to test the sending transactions, we have another wallet having 0.25 balance. And we will send some asset from our wallet. After logging in again, we will go to Polygon chain and send to the address of the other wallet 0.3. And now when we click on send transaction, it loads for some time. And now it succeeds. And if we check the balance of Polygon, we will find that it decreased to 0.19, taking 0.3 to send, and some and if we checked, can we go back? Yes, the balance here has increased with 0.3. As we can see, it was 0.2. And then we delete our wallet and try to import it from the mnemonics we saved before. So we create a new wallet with a new password and import the mnemonics we saved before. And when we import and log in again, we will find that the balance of Polygon is the same number as before, as we can see here.
At the beginning of the semester, we had our wallet implemented as a website. That was not convenient at all, especially that almost all the wallets out there are implemented as a browser extension, and it's more convenient than the website implementation. So we had take the project to be a Dahab wallet browser extension, as Omar has illustrated earlier. And in the process, we did not forget our fellow developers. So we created an npm package, very easy to use, very easy to install, and have very, very strong documentation launched at npm registry. So any developer now can have can install the library and use it and integrate it in any of their applications. This is the documentation for them, and we have some examples in the GitHub repo that the developer can see to have a glimpse about how to call all of our functions. So this is part of the documentation. So this create master wallet. All of the functions are in the GitHub repo and in the documentation of the npm registry. For the testing, we choose the unit testing to be our testing scheme. And this is part of our unit testing. This is for the npm package. We had each function tested in the unit test, and as you see, there were 7 test suites with 17 functions tested.
Next. Now these are our wallet browser extension features. For our wallet and keys, we have supported chains Ethereum, Polygon, Solana, and Casper, and we store keys locally, securely. And for bridging and routing, we support Ethereum, Polygon bridging and Ethereum, Solana bridging as well. And we have a proof of concept for Ethereum and Casper. And for usability, we have a browser extension, as we have shown you, and an npm package for developers to use.
So our main empowerment outcome was a commercialized product. So as Omar mentioned, we have satisfied all the needed features to meet industry level, and we have several revenue streams for this product as a browser extension. One of them is applying services fees, like applying a 0.5% swap fee. And the other revenue stream is white labeling and customization. For example, we can give our wallet and infrastructure to different companies, and they can use them under different designs or different features for different use. And we already got one expression of interest letter from WebDB Tech based in the United States, interested in collaboration with Dahab Wallet to streamline transactions in a private and convenient way to their clients. And also, as we mentioned, we have developed an npm package to facilitate wallet integration. And we have a weekly download rate of 750 downloads, as you can see in this screenshot, based on the npm registry. And also, we containerized our Dahab wallet app, and we uploaded the Docker image to AWS ECR to also facilitate the integration for the developers. So that's all. This is our team. And of course, we want to thank our supervisors, Dr. Adel and Dr. Sedky, for the continuous support. And thank you.